Hey, seventh graders. I'm back here with my little Mighty Mouse. Say hi, buddy. You're not meowing anymore? He's just meowing up a storm. So, yeah, you'll probably have to see him every time because I'm kind of obsessed with him right now. And he is adorable. And we have found out he likes popcorn, mashed potatoes, and yogurt so far. He's like a dog. He'll eat anything you put in front of his face. All right, so we are going to start changing decimals to fractions, okay? So this part just says, notice and wonder, fractions to decimal. So we know 1/2 hopefully is 0.5. 1/3 is 0.33333. And remember, we write that as 0.3 repeating. That's the repeating sign for when a decimal repeats. 1/4 is 0.25. A quarter is 1/4 of a dollar. 1/5 is 0.2. Now, 1/6 on a calculator is going to give you this number, 0.166666667, okay? That is not the answer. It's 6 repeating. Now, what a calculator does is it'll round the last number. So if the last number was a 6, it rounds it to a 7 to stop it. But this is really 0.16 with the 6 repeating, just the 6 repeating, okay? 1/7 is a long decimal. It's 0. It's a repeating decimal. 142857143. And the whole thing repeats. You would just literally have to divide that whole thing out to figure that out. Okay. 1/8. So anything divided by 7 is going to be a long repeating decimal. 1/8 is 0.125, and that's a terminating decimal. That means it stops. This is 0.1 repeating. That would go on forever. 1/10 is 0.1. And then 1/11, again, it rounds that last number. So this is really 0.09090909. Okay, so you have two kinds of decimals. You have terminating decimals. We have three kinds, kind of. That's when a decimal stops. In other words, you get a remainder of 0. And that would be something like 1/2, 1/4, 1/5, okay? All of those, okay? A repeating decimal is when you find a pattern. This little guy's swatting at my hand here as I'm doing it. Of repeating remainders, okay? And we'll see that when we divide some out in a second. Okay? So if we have a pattern of repeating remainders, in other words, I'm going to keep bringing down the same number. So repeating decimals would be like 0.16 with the 6 repeating, 0.1 repeating, 0.09 repeating. All of those are repeating decimals. You also have decimals that go on forever. Those are irrational numbers, okay? So the last one is irrational. It can't be written as a fraction, okay? And that's a number like pi, where it just goes 3.14159, and there's no pattern, okay? Or none that anybody has found in this lifetime. Okay, so in other words, it can't be written as a fraction because there's no way to write it. All right, so that just kind of talks about what fractions and decimals, or changing decimals to fractions. Here's where we're going to do the actual division. This is how we change a decimal to a fraction. This literally means 9 divided by 25. So if you do the long division for it, it's 25 goes into 9, right? Because you're dividing 9 by 25. And I am going to get a number that's less than 1 because this number is less than 1. So what I'm going to do is I'm going to put in a decimal, bring it straight up, and I'm just going to add a 0, okay? Remember, it's the does McDonald's sell cheeseburger method. Divide, multiply, subtract, check, bring down, and I'll write that out in a second. So I would say 25 goes into 90 3 times, because 3/4 is 75 cents. 4/4 would be $1, too much. 3 times 25 is 75. I would subtract. So that was my divide step. My multiply step was 3 times 25. Now I'm subtracting. That 8, make that a 1. Okay, my check step is really important because I have to check that this number is less than this number. My remainder has to be less than what I'm dividing by. Otherwise, I didn't go in enough times. If I can't subtract them, that means I went in too many times, okay? So my bring down would be bring down the next number. In this case, I would have to add a 0. And I'd say 25 goes into 150, or how many quarters are in $1.50, and that would be 6. Okay, and I get a 0 remaining. So 9/25 is equal to 0.36, and this is a terminating decimal. Okay. All right, so if I do the next one, I'm going to do 11 divided by 3. 11 divided by 30, I mean not 3. So 30 goes into 11. Okay, 30 doesn't go into 11. So I can put that 0 up top, which I probably should have on the first one too. So you put your decimal in, bring your decimal straight up. 30 doesn't go into 11, so I'm going to add a 0. All right, so if I'm trying to do this, I'm not going to say how many 30s go into here because I might not know my 30, but I do know my 3 times tables. 3 goes into 11 4 times, so 30, or not 4 times, 3 times. 4 would be too many, that'd be 120. But 3 would go into 11 3 times, so 30 would go into 110 3 times. Not evenly, but that's how I know not to go too much. I'm going to estimate. That's 0. 3 times 3 is 9. I'm going to subtract. I get 20 left over. I'm done with the decimal once I place it. You don't bring it down with you when you divide. I am done with it. Oh, here he comes. Okay. So I'm checking 20 is less than 30. So I'm going to bring down a 0. So I would say 30 goes into 200, or how many 3s goes into 20? Because I'm kind of estimating. Okay, 3 times 7 is 21, so that's too many, so I would do 6. 6 times 0 is 0. 6 times 3 is 18. Okay, and I'm going to get 0 when I subtract them. 20. And you're going to see the pattern right now. I had 20 the last time. I'm going to keep bringing down a 0 till I can't do it. 30 goes into 200. We literally just did this. 6 times 30 is 180. I'm going to get 20 remainder. Okay, so you're going to see, you're going to keep getting a pattern in your remainder. 20, 20. If I did it again, it would be 20. So that means that 6 repeats. So 11/30 is equal to 0.36 with the 6 repeating, not the 3. I'm not putting the bar over the 3 because the 3 does not repeat. Okay? All right. And then the third one, I've got 4 divided by 11. That's literally what that fraction's telling you. So it is 11 goes into 4, which we know it doesn't, hopefully. Okay, you gotta be careful you don't do these backwards. I'm gonna put in my decimal. It doesn't go into 4. Add a 0. Okay, all 11s are repeating decimals. I can tell you that right now. Unless it's 11 over 11. 11 goes into 40 3 times, because 4 would be too many. Then I'm going to multiply. 3 times 11 is 33. I am going to get 7 left over. 7's less than 11, so I'm going to bring down another 0. 11 goes into 70 6 times, because 7 would be too many. That's 66. Oh my God, get out of here. It's just a bundle of energy. So I would subtract that, and I'm going to get 4 remainder. 4 is less than 11, so I'm going to bring down a 0. 11 goes, and you're going to see the pattern right now. 11 goes into 40 3 times. 3 times 11 is 36. 3 times 11 is 33, I mean. I get 7 remainder. Add a 7 remainder there. Okay, so you're going to see the pattern. It's just going to keep going. It's 3, 6, 3, 6. So 4 11ths is equal to 0.36. Both of the numbers repeat, so I put a line over both numbers. Okay, so what is similar about your answers to the previous question? My answers are not rounded, okay, and I have some terminating and some repeating. So my answers were not rounded. I'm telling you that this will go 3, 6, 3, 6, 3, 6 forever. and I had some repeating and some terminating. Repeating, terminating. Just think, terminate stops. If you terminate something, it stops. So the decimal stops. All right, this one says use the decimal representation to decide which of these fractions has the greatest value. Okay, so I had 0.36, 0.36. I had 0.36 repeating, and I had 0.36 both repeating. All right, so what I would do is right now it's really hard to tell, but if I just kind of added some zeros on here, okay, or continued my, so this would just go 0, 0, 0, 0, 0. It doesn't matter how many zeros I add to it. This is going to go 3, 6, 6, 6, 6, 6, and it would keep going, right? This would go 0.36, 3, 6, 3, 6. All right, so these are all the same. These are all the same. Here's where I can tell a difference. So that guy is the highest, okay? So I kind of had to extend it a little bit to see which one was the best. All right, now this is telling us, and when we talked about pi before, when we did circles, you can use 22/7 for pi. It is the closest fraction. It is not exact, just like 3.14 is not exact. But if I divide out 22/7, okay, I'm going to say 7 goes in there 3 times. 3 times 7 is 21. I get 1 left over, okay? I have a leftover, so I have to add a 0. Do not make this 3.1 because you have 1 left over, okay? 7 goes into 10 1 time. 1 times 7 is 7. 3, I'm going to bring down a 0. 7 goes into 30. 4 times. 4 times 7 is 28. I'm going to get 2 left over. Bring down a 0. Okay, 7 goes into 20 twice. And remember I said pi is 3.14159. So if I 1,4 and I did 1 and that one was a 5, because if I keep going, that's just rounded, okay? So this number is going to keep going. This will never stop. So when they decided to use, when you shorten pi, you're just using the hundredths up to the hundredths place. So neither one are accurate, exactly accurate. They're the closest we can get to the fraction, okay? All righty, moving on. We're almost done with this one. All right, so this is kind of a little bit of what we did yesterday. Match the decimal with the bar graph, okay? All right, so I've got an increase by 1/4. I've got an increase by 1/3. I've got an increase by 2/3, an increase by 1/5, and a decrease by, decrease by 1/5, and a decrease by 1/4. Okay, would you stop? Holy moly. All right, so if I'm saying y is equal to, okay, I'm saying y is equal to 1 whole plus 1/3 of x. If this is x is 1/3, 2/3, 3/3, okay, I'm saying y is equal to 1 whole. If y is equal to 4/3 x is what I would write. Let me write that. Okay. So if I'm doing that, then if I say 4/3, that's 1 and 1/3. So this is an increase by 1/3. Okay. And then this is what the decimal would be. If I divide that out, I'm going to get 1.3. 1/3 is 0.3 repeating. This is 1 and 1/3. So it would be 0.3 repeating. Okay. This one I'm saying y is this, and it decreased by, this is 1, 2, 3, 4/4. Okay, so this is an extra 1/4, so I would say y is equal to, I'm going to say x plus 1/4, or 1 and 1, well, it's an increase of 1/4, or decrease of 1/4, I'm sorry. X is a decrease of 1/4. But if I were saying y is equal to, I would say the fifths. I'm sorry, not fourths. What am I doing? 1, 2, 3, 4, 5. It's a decrease by a fifth. And I didn't say that. That goes that one. Okay, so y is equal to 4/5 x. Which is 0.2, and it's not on there, but that's how I would write it. Okay, I guess I could write it as y is equal to, if I did these in fourths the way they're doing it, I guess I could write it as 0.75x. Yeah. Okay, because x is, if this is 1/4, 2/4, 3/4, 4/4, that's an extra fourth. So x is 3/4 of it. All right, we're not going to draw a diagram for the unmatched one because the diagrams are a little different. All right, so what I want to do is just real quick, when I did the does McDonald's sell cheeseburger thing, right? When you're long dividing, divide, multiply, subtract, check, bring down. Okay, that is it. You're just kind of changing a fraction to a decimal. You do that by dividing the numerator divided by the denominator. And if you're doing it in a fraction form, it's denominator goes into numerator. All right, have a fabulous weekend, and I will see you guys later. Bye.